We're going to talk about the very basics of database transactions and ACID properties in this video. Let's first start with database transactions. A database transaction is a way to group one or more database operations in a way that it can be executed as one indivisible unit. Let's say we have a bank account database and it has an account table, and we want to transfer money from one account to another account. Let's say we have account A and then we have account B. We want to move $50 from account A to account B. So for this, we need to do two different operations. First, we need to run an update statement to reduce the balance on this account by 50. And then we also need to run another update statement to increase the balance on this account, which is B, by 50. So these are two different statements that we need to run, or database operations that we need to run. But we want to run these two as one indivisible unit, because if the first statement runs successfully, as in we have successfully reduced the amount on this account A, but if we have not increased the amount on this account B, then the database will be in an inconsistent state, and we don't want that. If one of them fails, we want both of them to fail. We only want this whole operation to succeed if all the individual operations in it are succeeding. So this is where we'll use database transaction. So what we will do is we will begin a transaction, and within this transaction we'll first reduce the amount of account A by 50. Then within the same transaction we increase the balance of this account B by 50. Then we will commit this transaction. If the first operation fails, as in when we are trying to reduce the balance of account A by 50, if that operation fails, the second operation won't get executed. The whole transaction will be rolled back. Only when both the first and second statement have executed successfully, this will be committed. If the second operation fails after the first operation has completed successfully, the whole transaction will be rolled back, and any changes made by the first operation will also be reverted. So none of the changes will get committed. So this guarantees that whatever operation we have inside the transaction will run in an all or nothing fashion. This is how transaction works at a very, very high level. Now, any valid transaction must support something called ACID properties. So these are 4 different properties that must be supported by any valid transaction. This ACID is just an acronym for atomicity, consistency, isolation, and durability. Now let's look at each of them in detail. We have sort of already covered what atomicity means. Atomicity is nothing but all or nothing guarantee. When a transaction runs, it ensures that all the operations within that transaction are executed successfully, or none of them are executed. In our example, we have already seen that within this transaction we have 2 operations. If either one of these operations fails, then all the operations are rolled back. If all the operations have run successfully, only then we will commit that transaction. So that is what this atomicity means. And consistency means the data in the database will always be in a consistent state. This is very similar to atomicity, but the focus here is on the consistency of the data. So when we talk about consistency of the data, we're talking about the data integrity constraints like foreign keys, unique keys, and all those data integrity constraints are maintained before and after the transaction. Another way to look at this is, in case of this bank account transfer, we will not be in a state where money from account A is deducted, but it is not increased on account B. So we'll never be in that state. So this is another way to look at the consistency. So after a transaction has completed successfully, the data in all the records will be in a consistent state. Next one is isolation. Isolation simply means, at a very, very high level, if 2 or more transactions are running in parallel, then they'll be run without interfering with each other. So when we are actually transferring money from account A to B, and if another transaction is transferring money from account B to C, then there will be some mechanism that will guarantee that these 2 transactions will not interfere with each other. They'll be run without affecting each other. But there are different mechanisms to handle how these transactions will be running without affecting each other. Those are defined by something called concurrency isolation level. And the last one is durability. What durability means is that once a transaction has committed successfully, then no matter what, the data will not be lost, even in case of system failure. So in this case, we have completed this transaction where we have reduced the balance of account A by 50 and increased the balance of account B by 50. Now we have committed this transaction. Immediately after committing this, we have power failure or some sort of system failure. We can be sure that this data change is retained no matter what. Okay, so that is what durability means. We have looked at what a transaction is with an example, and we also looked at 4 properties of transaction which are called ACID properties. I hope this video is useful. Thank you.